Today's lesson is a review of simplifying radical expressions, focusing on radical expressions that are not perfect squares. So we'll start with the square root of 12. 12 is not a perfect square. So the way that we'll break this down, try to simplify this is, we're going to look for the greatest perfect square that is a factor of 12. Well, 12 can be rewritten as 4 times 3. And 4 is a perfect square. It's the greatest one that is a factor of 12. So I'm going to rewrite the square root of 12 as the square root of 4 times 3. From here, we can actually simplify that further. We know what the square root of 4 is. That's 2. So I'm left with 2 times the square root of 3. We'll do the same now with the square root of 20. So I'm looking for a perfect square, the greatest perfect square, that is a factor of 20. The greatest perfect square again in this case is 4. So 20 can be rewritten as 4 times 5. And now we can simplify. The square root of 4 is 2, so I'm left with 2 square roots of 5. We handle cube roots much the same way, except this time we're looking for perfect cubes. So I'm looking for the greatest perfect cube that is a factor of 16. Well, in this case it's 8. So 16 can be rewritten as 8 times 2. I know the perfect cube of 8 is 2. So I'm left with 2 times the cube root of 2. Let's try it again now with the cube root of 32. So I'm looking for the greatest perfect cube that is a factor of 32. And in this case, it's going to be 8 again. 8 times 4. So 32 can be rewritten as 8 times 4, where 8 is the greatest perfect cube that is a factor. And when we simplify this, the cube root of 8 is 2. And I'm left with 2 times the cube root of 4. Exponents are slightly different, but obviously the same concept because we're talking about square roots. So I'm looking for the square root of x to the 4th. So I'm asking myself, what times itself, what multiplied by itself is x to the 4th? Well, in this case, it's x squared. X squared times x squared. So I'm looking for the square root of this statement. Well, the square root of x squared is x. And the square root of this x squared is x. So I'm left with x squared is my answer. So what value multiplied by itself is x to the 4th? X squared is, right? X squared times x squared equals x to the 4th. If it's an odd numbered exponent, we can take the same approach. We're going to use our rules for multiplication of exponents with the same base. And we're looking for a perfect square that is a factor of x to the 5th. In this case, it's x to the 4th. So x to the 5th can be rewritten as x to the 4th times x. And then we find the square root of the factors inside the radical sign. So the square root of x to the 4th, we've already seen, is x squared. And I'm left with, in the radical sign, the square root of x. Just 2 more. Now we're looking for the square root of x to the 7th times y squared. Well, x to the 7th we can rewrite as x to the 6th times x. And y squared, well, that's already a perfect square, so I'm going to keep that as it is. So I'm going to put those under my radical sign. So let's start with the square root of x to the 6th. What multiplied by itself is x to the 6th? That would be x to the 3rd. x is not a perfect square, so we leave that as is. That's going to stay in the radical sign. And then y squared is a perfect square. The square root of y squared is y. So it's x to the third y multiplied by the square root of x. Lastly, we may get a problem in fraction form, but we handle this the same exact way as all the others. So I'm looking for the square root of 49. Well, in this case, I'm just going to rewrite this out first. So this is 49 times x to the fourth times x. That's my numerator. And on the bottom, we've got 4 times x squared. So I'm just breaking out the numerator and denominator to look for perfect squares. So now we can go ahead and simplify. The square root of 49 is 7. The square root of x to the fourth is x squared. The square root of x, that's not a perfect square, so that's going to stay inside my radical sign. And that's the numerator taken care of. Now we're going to look to the denominator. The square root of 4 is 2, and the square root of x squared is x. So here's one form of my answer. This technically isn't simplified all the way, though. We could simplify this further. So 7 squared, so 7x squared over x times the square root of x. The x's here can be simplified. Right? They both have an x in common, so we can use our division rules for exponents. And dividing exponents with the same base, this would be 7x over 2 times the square root of x, and this is actually the simplified answer. This is the one that we want. On MathSpace, they may give you credit for it, but they won't count it as the final answer. So this is what we want. There's an alternate way to get to that answer, and it goes like this. I'll do this one in green. We can start inside the radical sign first, and we can focus on right here and use our dividing exponents with the same base rule. So this would give me 49 x to the third over 4. Now I can go ahead and break this down, and I've got 49 times x squared times x over 4, and then look for the perfect squares there. So the square root of 49 is 7. The square root of x squared is x. I'm left with the square root of x. And for the denominator, the square root of 4 is 2. And there's the answer. This method's perhaps a little cleaner, a little quicker. So that's our review of simplifying radical expressions. If you need any help, email me and I'll get back to you right away.